Hello, my name is Yadavendra Kumar Yadav, and today we are going to study complex number. So, yes, so let's define what is a complex number. So, complex number, let's let Z be a complex number, and we represent Z as x plus iota y. So here we need to define what is x, what is iota, what is y. So actually x and y are real numbers, real numbers, and iota is equals to root under minus 1. And this is definition of iota. Now, uh, if z is complex number in the form of x plus iota y, here x is called as real part of z, real part of z. In short, we write like this: r is z, which is x. Now, y is actually imaginary part of z. Imaginary part of z, and in short, we write im of z, and that is why. Now, now we need to define few properties, few definitions, few terms. So next, if we are given z bar, if we are given z as x plus iota y, then z bar is a term that is called as conjugate of complex number, and that is conjugate of z, and it can be written as x minus iota y. And if you try to understand here what is real and imaginary part of z bar, then re of z bar, it's similar, x, and im of z bar means imaginary part of z bar is going to be minus y. So now it's clear what is real part, what is imaginary part. Then there is a term called modulus of z. Modulus of z is distance of z, distance distance of z from origin, from origin 0 0. And of course this distance is going to be root under x square plus y square. And this distance we will also prove it is x square plus y square when we will come to representing a complex number in imaginary plane. And when it will come, we will do that. After these two terms, actually we should start some algebraic things. It is very simple. Like if you are adding 2 plus x as one number, and in this if you are adding 3 minus 4x, so result is very simple, that is 5 minus 3x. Similarly, complex number addition take place. So consider z1 is defined as 2 plus iota, and z2 is defined as 3 minus 4 iota, right? So what will happen? Z1 plus Z2? Z1 plus Z2 is going to be 2 plus iota, 2 plus iota, and plus 3 minus 4 iota, right? So then this term is going to be 5 minus 3 iota, right? Then let's calculate Z1 minus Z2. So it will be similarly 2 plus iota minus 3 minus 4 iota. So that is going to be 2 minus 3 is minus 1 and iota plus 4 iota. So that will be plus 5 iota. Sorry for this, not 3, 5. So plus 5 iota. So this is subtraction. Now come to multiplication. Z1 into Z2. So that is going to be 2 plus iota into 3 minus 4 iota. Multiply as it is. 2 into 3, 6 minus 2 fours are 8 iota. Then plus 3 iota. And then minus 4 iota square. Now, what is definition of iota? Root under minus 1. So you can recognize that iota square will be minus 1 by the algebra, right? So now it is 6 minus 8 iota plus 3 iota, and this iota square is minus 1. So this will become plus 4. So this is going to be finally 10 minus 5 iota. This is our multiplication result. Similarly, we will have division result, Z1 upon Z2. So Z1 upon Z2 is going to be 2 plus iota divided by 3 minus 4, 3 minus 4 iota. So multiply this by 3 plus 4 iota and divide this by 3 plus 4 iota. So numerator is going to be 3 to the 6 and plus 3 iota and 4 to the 8 iota and plus 4 iota square and whole divided by it's 3 square minus 4 iota square. So numerator is going to be 6 plus 8 and 3, 11 iota minus 4. And divided by this is going to be 9 minus 16 iota square. So now further this can be written as 6 minus 4 is 2 and plus 11 iota and whole divided by 9 plus 16. Why 16? Because this iota square is minus 1. So it is going to be 2 plus 11 iota whole divided by 25. And finally, we can write 2 upon 25 and plus 11 upon 25 iota. So here, now we can observe that addition of two complex numbers, subtraction of two complex numbers, division of two complex numbers, all of them are resulting in a new complex number in the form of x plus iota y. Here, don't do one mistake that initially I have not defined those things, classification of complex number, but you need to understand that a real number, set of real number is actually subset of complex number. Let's denote the set of complex number by C, and this is set of reals, and this is set of complex numbers, set of complex numbers. So if you come to the classification of C, by that we denote complex number, it comes two things. So one is real numbers and another is imaginary numbers. So real numbers example 1, 2, 3, minus 1, 0, root 7, 0 0.3, 0 0.01, 0.2, 0.3, 0.04, so on, right? So these kind of numbers, root under 2 by 9, these kind of numbers, right? Imaginary numbers, root under negative, like root under minus 17, root under minus 13, then 3 minus 2 iota. So if you are looking together a complete number 3 minus 2 iota, it's imaginary number. Of course, it's a complex number, but in complex number, this is imaginary number. What about 5? 5 is a complex number or not? Yes, 5 is a complex number. Complex number. Right? So you need to understand, see, though I have already written that real number is subset of complex number, still students hesitate to say 5 is a complex number. Of course, 5 is a complex number. 3 minus 2 iota is a complex number. So 5 is also complex number. 3 minus 2 iota is also complex number. 3 minus 2 iota in complex number, this is imaginary, right? Sorry. Yes. So in complex number, this is imaginary number, and 5 is a real number. But 5 is also in real. After real, 5 is also a complex number. So if you try to locate, try to draw a rough diagram for complex number. So if this is complex number set, then inside it somewhere is real numbers. Somewhere something like this, it's real numbers. In real number, we have rational numbers. So this is complex number set. This is real number set. Then we will have a rational number set here, Q. In Q, integers comes, right? Denoted by I. Then inside integer, whole number will come. Then inside whole number, natural numbers will come. So this is the classification if you try to do. Now let's move further. So now let's represent complex number on imaginary plane. So how do we represent? So it's like there is one line, and then we will have another line. Then we will have another line, and then we will define terms, right? So this is called real axis. Real axis. And this is called imaginary axis. This is imaginary axis, right? And of course, this is x-axis, similar as our coordinate system, and this is y-axis. So y-axis is called as imaginary axis, right? So here, how we are going to represent a complex number z is equal to x plus iota y. So to represent this, we draw a picture like this. If this is the point z, then here the distance from x-axis, which is y, and distance from y-axis, which is x. And then I told you initially that when we will come to the diagram, then I will tell you what is modulus of z. So this is actually modulus of z. If you call this point as P, and this origin is O, then OP is actually modulus of Z, and which is, of course, it's a right angle triangle. So root under perpendicular square plus base square, right? Which is root under x square plus y square, right? So this term is x, right? Now, here we define what is the angle made by complex number in anti-clockwise direction from the x-axis, right? Positive x-axis. So we will define theta, and this theta is called as, let's say this angle called theta, and this theta is called as argument. Argument, right? And to calculate argument, we need to define alpha, right? So what is this alpha? So we will come to this. So alpha is equal to tan inverse modulus of y upon x. This is alpha. And theta varies according to the quadrants, right? So theta is argument, theta will be equals to alpha, right? If Z is in first quadrant. Z is in first quadrant. First quadrant. If it is in second quadrant, then this theta argument is going to be pi minus alpha. If Z is in second quadrant, then if we are given the complex number Z in fourth quadrant, then okay, let's call third first, right? So then theta is going to be alpha minus pi, right? So if Z is in third quadrant, third quadrant, right? And theta will be equals to minus alpha if Z is in fourth quadrant, right? Okay, so what is logic behind this? Why we need to define alpha? So it's very simple. I will try to elaborate here. So if our Z is here in first quadrant, then you can understand that alpha and theta will be equal. If you are coming to second quadrant and calculating the alpha, you will get this angle. But theta is argument, and argument you have to calculate from the positive x-axis from here in anti-clockwise direction, right? So of course, if you try to calculate this angle, this bigger angle from the x-axis, then this angle is going to be pi minus alpha. If it is in fourth quadrant, then Z will be in fourth quadrant. If you try to calculate alpha, alpha will be this angle, right? So of course, it is going into clockwise direction. So direction is opposite, so value will be negative. So in this quadrant, theta will be minus alpha. But if you are coming to the third quadrant, so in third quadrant, if you are looking at alpha, then after calculation, you will get alpha as this angle. But you have to calculate angle this one, this angle, right? So keep in mind, anti-clockwise is the positive angle, and if you are going clockwise, it's negative angle. So now how we are going to calculate this angle? This angle. So to calculate this angle, which is in third quadrant, so what we will do, we will move little extra. We will go up to here. So this is minus pi. And then alpha angle we are moving. This alpha angle we are moving in clockwise direction. So alpha is plus. So that's why if you look at this value is similar as alpha minus pi. And so I have written here alpha minus pi. Look at this third one, right? So this is called argument. Argument has another name as well, that is amplitude also. So some book call it amplitude, but argument is the most general word we use for the angle theta, right? And modulus is modulus. Modulus is modulus, right? Now argument is also called as amplitude. Right. After this, we are moving next. So there is a polar form, right? So if you look at this, e to the power iota theta, if you look at e to the power iota theta, then this expansion is going to be 1 plus iota theta plus iota square by 2 theta, 2 factorial, plus iota cube theta cube by 3 factorial plus iota power 4 theta power 4 upon 4 factorial plus iota to the power 5 theta to the power 5 factorial plus iota to the power 6 theta to the power 6 upon 6 factorial and so on. And here in short, I will try to tell you one more thing, that powers of iota. Iota is iota. Iota square is -1. Iota to the power 3 will be minus iota. You can understand, right? And iota to the power 4 will be +1. How? See, iota square is -1. Do a square both side. So this will be iota to the power 4. And right hand side is going to be 1. So iota to the power 4 is going to be 1. Now, so this e to the power iota theta can be written as, if we simplify the series, it is going to be 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial minus theta to the power 6 by 6 factorial and so on, plus iota times. It is going to be theta minus theta to the power 3 by 3 factorial plus theta to the power 5 by 5 factorial and minus so on. So signs will come alternate. So according to the sine and cos series, we are given cos theta plus iota sine theta. And this is polar form of a complex number. This is called polar form of a complex number. Form of a complex number. Then question arises how we are going to convert from Cartesian form to polar form. So I have not said what is Cartesian form. So the simple one that we learn initially, x is equals to z is equals to x plus iota y. So this complex number z is in the form of Cartesian form. Right now, this can be also written as modulus of z e to the power iota theta. And now this is polar form. So what is this z is going to be? It is going to be root under x square plus y square and e to the power iota theta. How we calculate theta? According to the quadrant. Same process. Theta is alpha. Theta is pi minus alpha. And theta is alpha minus pi. And theta is minus alpha according to the quadrant. First quadrant, second quadrant, third quadrant, and fourth quadrant. So we define like this. And how we calculate alpha? So alpha will be tan inverse of modulus of y upon x. So this way we calculate alpha. Now, after this, we will move to cube root of unity, nth root of unity, or nth root of a complex number. So nth root of unity first. So cube root of unity first. Okay. So cube roots of unity. Unity means 1. Meaning we will solve the equation x cube is equals to 1. Right? And this equation will have 3 possibilities. Right? So solve x cube minus 1 is equals to 0. We will get x minus 1 times x square plus x plus 1 is equals to 0. So if you solve, we will get x is equals to 1 and x is equals to minus 1 plus minus root under 1 square minus 4 into 1 into 1 and divided by 2 into 1. So this is going to be minus 1 plus minus root 3 iota. Why? Because root under minus 3 can be written as root under 3, root under minus 1, and this will be root under 3 iota. Right? Now, divided by 2. So here I am going to define that these 3 things. First root as 1, another root as omega, and another as omega square. Why I am assuming like this? Actually, Here 1 root minus 1 plus root 3 iota by 2. So if you will square this, you will get another one. So minus 1 minus root 3 iota by 2. So that's why. And it's vice versa also. Like if you are doing a square of second one, you will get first one. So they are a square of each other, right? So generally this combination not possible in real number system, but this is complex number system. So if you will call here this thing as omega, this will be omega square. Here you will call this thing as omega, this will be omega square. Now coming to the equation. So equation was x cube is equals to 1, right? So this can be written as x cube minus 0x square, sorry, plus 0x square plus 0x minus 1 is equals to 0. So here sum of root 1 plus 1 plus omega square. Sorry for this. So now 1 plus omega square, and sum of root is minus b by a. So this will be 0, right? Now product of root, so 1 into omega square, and that is going to be minus d by a. Sorry, minus d by a, but minus d by a, but this d is minus 1, so plus 1 by 1, that is 1. So what actually we are getting, omega cube is equals to 1. And that also can be put into the original equation. This is our equation. Equation 1 is the original equation, x cube is equals to 1. Omega is root, if you will put, so omega cube is equals to 1. Of course, it will satisfy the given equation, right? So it is satisfying. Now, if you are putting omega square, because that is also root, so omega square to the power 3, that will be omega to the power 6, can be written as omega to the power 3 whole to the power 2, and omega cube is 1. So 1 square, which is 1. So omega square will also satisfy. Now, this was cube root of unity. Now we will move to nth roots of unity and how we are going to deal with that. So nth root of unity, and this when I will represent, when I will calculate algebraically nth root of unity, then I will move to the rotation part. So now x to the power n is equals to 1. Then it can be written as x to the power n minus 1 is equals to 0. Now this can be written as x minus 1 times 1 plus x square plus dot plus x to the power n minus 1 is equals to 0, right? So here you can understand that one root is 1, and another thing is 1 plus x square plus dot plus x to the power n minus 1 is equals to 0. So another n minus 1 roots will come from here, right? And those roots are going to be omega square, omega to the power 3, and dot omega to the power n minus 1. See, don't get confused with cube root of unity. In this case, omega to the power 3 is not is equals to 1, right? So here our n is not 3, our n is n. So here what will be the property? As omega is root 1. So here your equation 1 is this. So here it will satisfy omega to the power n is equals to 1. Now, last time we had omega values. Now what will be omega values? we will go to that. So that can be done in only in one manner, by converting into polar form. So x to the power n can be written as 1. 1 can be written as 1 plus 0 iota. This can be written as x to the power n is equals to 1 can be written as cos pi by 2. Sorry, sin pi by, sorry, cos pi, cos cos 0 will be 1, sin 0 will be also 1, but we are not talking about 0. We are talking about general form. So n pi. N is already there, so k pi. So this 1 can be written as cos 2k pi plus iota sin 2k pi, where k is an integer. K belongs to set of integers denoted by z, or if it is confusing, denote it by I. Right, so don't get confused. Here it is set of integers, you can denote it by I, no problem. Right, so then this right hand side can be written as x to the power n, and this cos 2k pi plus iota sin 2k pi can be written as e to the power iota 2k pi, sorry, 2k pi, 2k pi, right? Then if you try to calculate x, then it will come e to the power iota 2k pi and whole divided by n, right? And here we will put k is equals to 0, 1, 2, 3, and dot, 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 up to n minus 1. But some people are thinking, sir, keep putting k is equals to n also, n plus 1 also, n plus 2 also. So what will happen? Roots will start repeating. So if you will put n, then the similar root you will get at where you are getting at k is equals to 0. You will put n plus 1, similar root you will get what you are getting at n is equals to 1. Right? So similar root you will get n plus 2. So likewise, you can understand. So roots will start repeating. Okay, now start representing these roots on x-axis. So if, sorry, on the plane, imaginary plane. So this complex number whose x to the power n is 1 is going to be represented here. So if you put k is equals to 0, and if you look there, that number is going to be 1. So 1 is here. Then here another number will come, and you will see the angle as 2 pi by n. That angle will be here. Put n is equals to 1, this one, this one. So you will get 2 pi by n. So all angles are actually 2 pi by n. Next angle will be also 2 pi by n. Why 2 pi by n? Because all n roots are there and they are equally located on this unit radius circle. So this radius is 1. So you can understand this point is 1 comma 0, right? And if you look at this point, minus 1 comma 0, that does not matter, right? Now here if you are looking the angle, so if you represent this by omega, the next will be omega square. Next root will be omega to the power 3. And so on. This last root is going to be omega to the power n minus 1. So these roots are there, these many different roots, and every time you will see that one root you are multiplying by the omega, you are getting the next root, right? So all the roots can be written in the form of, so or in the form of omega powers, right? So first thing is 1, so that you can understand like this, omega to the power 0. then omega, so which is omega to the power 1, and its value is, omega value is e to the power iota 2 pi by n. Then omega square is coming, right? So it will come e to the power iota 4 pi by n. Actually, this can be written as e to the power iota 2 pi by n whole square. Now, then omega to the power 3 will come. This is e to the power iota 6 pi by n. And this can be written as e to the power iota 2 pi by n whole to the power 3. Similarly, omega to the power 4, it will keep coming, right? So e to the power iota 8 pi by n, and it will come e to the power 2 pi by n iota whole to the power 4. So last will be omega to the power n minus 1, which is e to the power 2 pi by n iota whole to the power n minus 1. So these are the roots of unity. And if we want to deal with general complex number nth root, like one complex number is simply z, and we want to deal with roots of z, nth root of z. So this can be written as modulus of z e to the power iota, and call its initial angle with x-axis as alpha. So e to the power iota alpha, right? Now, so how we are going to deal nth roots? So take both side power 1 by n. So it will become, sorry, let's assume initially z to the power n is equivalent to z1, a complex number z1. Now, if you want only z, then it is going to be z1 to the power 1 by n. And this way it will be easy to understand, so I erase the previous way. Now, z1 also can be written as modulus of z1 e to the power iota alpha, right? This alpha is initial angle with, so this alpha is, if your z1 is this, then this is the angle alpha what z1 is making with x-axis in the positive direction, right? So now this to the power 1 by n. Now, if you look at the rotation, so this can be also written as modulus of z1 and e to the power 2k pi plus alpha. You will get same number z1. So 2k pi plus alpha and whole by, sorry, alpha iota whole 1 by n. This can be written as modulus of z1 to the power 1 by n into e to the power iota 2k pi plus alpha by n, and here again k is equals to 0, 1, 2, 3, and so on up to n minus 1. Again, similar like previous. If you will move further in n k is equals to n plus 1, n plus 2, roots will start repeating, right? Now, moving to the geometry of complex numbers. So, and in that rotation is very important. So, if we will come to geometry of a complex number, then complex number behaves like a vector. Why? Because consider a vector, vector b, this can be written as 2i plus 3j in 2D, in 2D, right? Look at complex number z. This can be written as x plus iota y. So similarly, no, here is also two component, x component, y component. There was also x component, y component. That's why complex number have a similar behavior as vector. How? Let's see this. So let's call this complex number as Z1, and some another complex number here is Z2, right? So this complex number is going to look like something like this, and this will be the resultant. So this top is going to be Z1 plus Z2. This is the property of vector, right? Yes. Now, here, let's name the point 0. This Z1 complex number is at point P. This Z2 complex number is at point Q. And this Z1 plus Z2 complex number is at point R. So this point is R. So now you will understand that modulus of Z1 is actually the distance OP. And this distance OP is similar as the distance QR, right? And because as OPRQ is a parallelogram, right? Next, moving next. So after this, now rotation of complex number is coming. So let's, if you are given a complex number Z, and this Z is looking like this, that it is making angle theta, and this X is, this Z is X plus iota Y, the given general form, right? So if you multiply Z by e to the power iota alpha, then it will rotate by alpha, right? So, so, so here, if this angle is alpha, then this point is going to be Z into e to the power iota alpha. How? Because Z is also modulus of Z e to the power iota theta. Then Z into e to the power iota alpha is going to be modulus of Z into e to the power iota theta into e to the power iota alpha. This can be written as modulus of Z into e to the power in bracket theta plus alpha iota. Right? Then you will realize this complex number, which is at angle alpha plus theta, have the same magnitude, not amplitude. Magnitude. Magnitude means the modulus. So here modulus is also Z, and they are at alpha unit rotated. It got alpha unit rotated. So similarly, if you multiply Z by iota, then Z is modulus of Z e to the power iota theta. So you will realize, sorry, this can be written as e to the power pi by 2 theta. E to the power pi by 2 iota. Now, iota can be written as 0 plus 1 into iota. 0 can be written as cos pi by 2. Plus 1 can be written as sine pi by 2 iota. So it is cos theta plus iota sine theta for me. This can be written as e to the power pi by 2 iota. So now here you will understand. And what modulus of Z? Sorry, what is Z? Z is modulus of Z into e to the power iota theta. Z is modulus of Z into e to the power iota theta. Now it will become modulus of Z into e to the power, take iota common, theta plus pi by 2. So now the position of Z is got changed by 90 degrees. So here if it is Z, then here at 90 degree, it will be iota Z or Z iota, right? So angle between them is iota Z. So origin Z and iota Z. So origin Z and iota Z forms a right angle triangle. Similarly, if you look at Z iota Z, so if this is a complex number Z and this angle is 90 degree, this is origin O, so this complex number is going to be Z iota or iota Z. But then by vector property, summation of vector property, vector A, vector B, so this is going to be Z plus iota Z. So similarly, Z, Z plus iota Z and iota Z, they are also right angle triangle. So these points forms a right angle triangle, forms a right angled triangle. Similarly, O, Z and iota Z forms right angle triangle. Right angled triangle. No. So after this, if we are moving next after the rotation property, so like I said, it has vector property as well. So consider a complex number, angle between them. Consider this is Z1, this is Z2, and this is Z3, right? And this length is equals to this length, and angle between them is theta. So it means what will be this vector, this first vector called, so it is going to be Z2 minus Z1, right? And then you are moving into anti-clockwise direction angle by theta. If you multiply this by e to the power iota theta, then you will get the next vector, that is Z3 minus Z1, right? But consider Z1, Z2, Z3, this is first case, right? Z1, Z2, Z3, they are not equal. Sorry, there, there is a triangle given Z1, Z2, Z3. So all this is Z1, this is Z2, this is Z3, and we are discussing this situation. Then Z2 minus Z1 and divide by its magnitude Z2 minus Z1, right? It will become a unit vector. Similarly, Z3 minus Z1 divided by modulus of Z3 minus Z1. So both side, this side also unit vector, this side also unit vector. So if you rotate one vector by theta, call this angle theta, you will get another vector, e to the power iota theta, and this is a relation of the angle of a triangle whose vertices are Z1, Z2, and Z3, right? After this, if consider 4 points are given, something like this, call this as Z1, Z2, Z3, and Z4, and call this angle as theta, right? So here situation is going to be and Z3 minus Z1 divided by modulus of Z3 minus Z1. And if you multiply this by e to the power iota theta, then it is going to be modulus of, sorry, Z2 minus Z4, Z2 minus Z4 divided by modulus of Z2 minus Z4. Now, so unit vector rotated by theta, you are getting another unit. It's done. So this is the relation if four complex numbers are given. This is third rotational relation. Four different complex numbers are given. Now we are moving next. Rotation only. Consider the fourth one. So arguments, they are getting log property. That is because of this rotation only. Like if we are looking at argument of Z1 into Z2. So it is going to be argument of Z1 plus argument of Z2. How? See, Z1 can be written as Z1, Z2. So this can be written as modulus of Z1 e to the power iota theta 1 into modulus of Z2 e to the power iota theta 2. So what we are getting? We are getting modulus of Z1 Z2 into e to the power iota theta 1 plus theta 2. So what we are getting at the end? That amplitude of Z1 and Z2, argument of Z1 and Z2 is coming argument of Z1 plus argument of Z2. Similarly, argument of Z1 by Z2. So this is going to be argument of Z1 plus argument of Z2. Sorry, minus log property. Minus. Why this minus? Similar as previous. So Z1 upon Z2 Z1 can be written as modulus of Z1 e to the power iota theta 1 divided by modulus of Z2 e to the power iota theta 2. This can be written as modulus of Z1 by Z2 and e to the power iota theta 1 minus theta 2. Now we can see this is argument difference. So that's why this is second one. Property of logarithm. Now, what will be argument of any positive real number? So it will be 0, first one. Why? I will elaborate later on. And argument of negative real number. If you look, it will be pi. Third one, argument of imaginary number of purely imaginary number with imaginary part positive, then this is going to be pi by 2. And similarly, argument of purely imaginary number with imaginary part negative. And this is minus pi by 2. Okay, how it is getting done? Very simple. So argument, I will give examples of 5. Right, argument of 5 is 0. Argument of minus 7 pi. Argument of root 3 iota pi by 2. And argument of minus 7 iota minus pi by 2. Why? Because first 5 is a positive number sitting here. Now minus 7 sitting here, right? Root 3 iota sitting here, and minus 7 iota sitting here. So in this case, angle is minus pi by 2. In this case, angle is plus pi by 2. In the case of 7th iota minus 7, it is pi. And itself 5 here, 5, argument of 5 will be 0 degree, means 0. Right. So this way argument goes. Now, a few things are left out regarding locus and all. Right. So in the case of locus, what things are going, and distance between two complex numbers, Z1 and Z2, it is going to be modulus of Z1 minus Z2. And if you calculate this, it will come as x2 minus x1 whole square plus y2 minus y1 whole square, where Z1 is given as x1 plus iota y1 and Z2 is given as x2 plus iota y2. These things are there, small things I have not mentioned initially. This is simple observation anybody can do. After this locus, so similarly using distance formula, so modulus of Z minus Z1, if this quantity is given as A, we will have three situations. So if A is positive, we will have a circle, and if A is equals to 0, and this will be a point, and this point will be Z1 itself, and if A is negative, then no locus possible. Sometimes people say it imaginary circle. Nothing like imaginary circle. Now, so this is first thing for circle. If you come to a second thing, so if somewhere is given modulus of Z minus Z1 plus modulus of Z minus Z2 is equals to 2a, and this is positive, then actually it represents an ellipse. An ellipse, right? And this sum of distance, if it is given 0, then sorry, if sum of distance is less than 2, less than 0, then there is no locus possible. So if we are given modulus of Z1 minus Z2 plus modulus of Z1, not Z1, Z minus Z1, Z minus Z2, Z minus Z1, Z minus Z2. This is 2a and this is negative. So this will give us no locus. So these things are there. Then difference of distance is constant, so hyperbola. Something like this. Modulus of Z minus Z1 minus modulus of Z minus Z2 is equals to 2a. And then here 2a can be negative, positive, that does not matter. So here it will give hyperbola. Hyperbola. And 2a is 2A is one is transverse axis and another is conjugate axis, right? So it is 2A will be transverse axis length, right? In this case, in the case of ellipse, 2A is major axis. Now, straight line properties are also there. So like if modulus of z minus z1 upon modulus of z minus z2 is equals to k, then two situations are there, right? So if k is equals to 1, this will tells us a straight line, a straight line. If k is not equals to 1 and k is positive, then circle, circle, and if k is 0, then it will be a point. So if k is 0, then this will give us a point. Very simple, right? Which point will be that? Point will be Z1. So this is for a straight line situation. Okay, so I will end lecture here and further things there, then I will upload later on. Thank you.